Alright, so welcome to the video for lesson number 5 on polynomial identities. So essentially in this lesson we're proving identities. So we're trying to make it so that one side of an algebraic equation is equal to the other. So we're going to have to either do some multiplication, some combining of like terms, or reducing in some way to make them look the same. So let's take a look at this first one. Looks complicated, but it's really not as bad as it looks. So for that first expression squared, if we use the trick from the lesson today, we have x squared plus 2xy plus y squared. If we do the same thing for the second expression, we get x squared minus 2xy plus y squared, and we wind up having that all equal to 4xy. Now, if you're looking at this screen and saying, how did he do that? Just take your boxes and do the box thing out. That's totally fine too. Nothing's going to be wrong if you do it that way. It just takes longer, that's all. So now if we start combining like terms, I see x squared and negative x squared. Well, that's nothing.
Cursing you first.
Alright, so if you start combining your like terms here, sorry about the fire drill by the way, you'll see that the x squareds and the y squareds will cancel, and because of this double negative, you're going to wind up getting 4xy equals 4xy. So that works. Alright, for this next one, we have m plus 3 cubed. Well, that's just m plus n, m plus n, and then m plus n. So we're going to have to do two sets of multiplication here. Now to kind of keep things easier, if you understood the rule from today, we have m squared plus 2mn plus n squared, and then m plus n gets multiplied. Now there's no kind of quick trick or rule to do that, so you actually have to just do the multiplication out. So I'll make some boxes here. So I have m squared, 2mn, and n squared, m, and n. So that's going to give me m cubed in that first box, m squared n in the second box. If you're trying to figure out which one goes first, always go alphabetical. 2m squared n, 2mn squared, mn squared, and n cubed. If you combine your like terms, we're going to wind up getting this m cubed plus 3m squared n plus 3mn squared plus n cubed. Alright, the next one asks us to identify some Pythagorean triples here. So it says this identity can be used to generate Pythagorean triples. Show that this statement is an identity. So all we're really doing here is multiplying again. So if we do some multiplication here, so we're going to wind up getting x to the fourth plus 2x squared y squared plus y to the fourth. Again, I'm using the rule from today's lesson to do that. If you don't understand it, make your boxes. It'll work just fine. If we do the same thing on the other side, I wind up having x to the fourth minus 2x squared y squared plus y to the fourth plus 4x squared y squared. If you combine your like terms here and here, we wind up getting the same thing on both sides. So I have x to the fourth plus 2x squared y squared plus y to the fourth on both sides of this equation, proving this is an identity. So now if we have this as an identity, that tells me that I can plug in x values and y values to generate Pythagorean triples. So for this last step, you just had to pick an x and a y number where the x value is bigger. So you could have picked any numbers you wanted. So essentially there's no real way for me to give you an example here that's going to check yours that you did, right? I will do 1 just so you could see what we did. So I'm going to pick 3 for x and 2 for y. But you can pick any numbers you want there as long as the x value is larger than the y value. So if I plug in 3 and 2, so I have 3 squared plus 2 squared. So I have 3 squared plus 2 squared squared. We have equals 3 squared minus 2 squared, that's why you had to make the x value bigger, squared, plus 2 times 3 times 2 squared. Now if you do some quick multiplication and do all these out, you're going to wind up getting 3 values here that are squared. Those 3 values are a Pythagorean triple. So if I do 3 squared plus 2 squared, I get 13 squared. If I do 3 squared minus 3 squared, we get 5 squared. And 2 times 3 times 2 is 12. Which tells me the triple that I got here was 5, 12, 13. I hope this video helps, and keep watching them to check your homework, please.